Okay, so let's continue with our practice of solving equations using index laws. Before getting into any more difficult examples, let's just review an example from the last tutorial, the last video. So remember that we need to make everything in terms of power of 3. So what we'll do is we'll leave the left-hand side alone and write 27 as 3 cubed. Since the bases are now the same, we can just equate the exponents. And then simply solving this equation, we get 2x equals 4, and so x equals 2. Okay, moving on to a more difficult example. Here we want to solve 2 to the power of 3x times 4 to the x minus 1 equals 32. So again, we express everything in terms of a power of 2. So we have 2 to the 3x times, we'll write 4 as 2 squared, and we can write 32 as 2 to the power of 4. Now the third index law allows us to simplify this second product, and what we get is 2 to the 2 times x minus 1 is 2 to the 4, and we can write that as 2 to the 2x minus 2, just expanding this out, equals 2 to the 4. Now the first index law tells us that we can now add, so I get 3x plus 2x minus 2 equals 2 to the 4. And then if we just bring this up here, what we find is that we have 3x plus 2x, so that's 5x minus 2 equals 2 to the 4. Now that the bases are the same, all we need to do is equate the exponents, and we get 5x minus 2 is equal to 4. Taking the 2 over, we get 5x equals 6, and finally x is equal to 6 over 5. Okay, let's look at this even more complicated expression. So again, as always, we try to express everything in terms of a power of 3. As you'll soon see, this 12 doesn't really matter, so I'm not going to convert that to a power of 3, nor can I. So let's just express everything else as a power of 3. So 9 to the power of x can be written as 3 squared to the power of x, or in other words, 3 to the 2x. Or I can even write this as 3 to the x squared. This is already in terms of a power of 3, and I don't even have to actually change 27 either. Now, if I've just done this, what I'll find is that 9 to the x minus 12 times 3 to the x plus 27, that's now equal to 3 to the x squared minus 12 times 3 to the x plus 27. Now, the reason why I know not to change this 12 or this 27 is because I see the following. I say, let u equal 3 to the x. Then what does this become? This becomes u squared minus 12u plus 27 equals 0. And this I know how to solve because this is a quadratic equation. So how do we solve quadratic equations? We can either factorize or we can use the quadratic formula. In the previous video I used a factorization technique, so let's just use the quadratic formula this time. Remember, if I have ax squared plus bx plus c equals 0, then I can express the solution as x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And now what do we have here? Well, the x is u, so a is equal to 1, b is equal to minus 12, and c is equal to 27. So if we insert those values into the formula, what we find is that u is equal to 12 plus or minus the square root of 144 minus 4 times 1 times 27, all divided by 2 times 1. And let's simplify this some more. So I get 12 plus or minus the square root of 144 minus 4 times 27. What's 4 times 27? That's the same as 2 times 54, which is 108, which is then divided by 2. If we simplify what's in the square root, we get 144 minus 108. So what is that? Well, that becomes a 3, 14, I get a 6, I get a 36 there. So we get 12 plus or minus the square root of 36 over 2, which is 12 plus or minus 6 over 2. And this is 18 over 2 or 6 over 2. And that's just 9 or 3. So we have this quadratic equation. We can factorize it as, well, we couldn't factorize it immediately or use the result from the quadratic formula, which is u minus 9, u minus 3 equals 0. So what we find is u is equal to 9 or u is equal to 3. And, well, we don't want u, we want x. So we know that 3 to the x equals 9 or 3 to the x equals 1. And now we just have a case of the equations we considered in the previous video. So if 3 to the x equals 9, we know that 3 to the x is equal to 3 squared, so x equals 2. So this equation has x equals 2 as a solution, and this one has 3 to the x equals 3 to the 0, so x equals 0. And those are our two solutions to this equation. Now, it may seem difficult, all this procedure of converting it to a quadratic equation and then solving the quadratic equation, but after you do about 5 of these, you see it very quickly that this is exactly what you're supposed to do. So just to reinforce this, let's do another example. So we have solve 16 to the power of x minus 5 times 4 to the x plus 4. Notice that the form is exactly the same. So the base that we chose here was 3. The base we want to choose here is 4. So I'm going to write 16 to the power of x as 4 to the x squared. And then we'll have minus 5 times 4 to the x plus 4 equals 0. That's exactly the same as this, except for the 12 has now moved to a 5, 27 has become a 4. So now we do exactly the same thing. We let u equal 4 to the x, and now we just convert it to a quadratic equation. So what we get is u squared minus 5u plus 4 equals 0. And let's just factorize this for convenience. So I get u minus 4, u minus 1 equals 0. So u equals 4 or u equals 1. And u is 4 to the x, so we get 4 to the x equals 4, or 4 to the x equals 1. And this is exactly what we're used to. So the first one is just x equals 1, and the second one is x equals 0. Very simple once you see this form. And be sure to just keep practicing. These are not as difficult as they may first seem.